Okay, awesome. And then I'm going to hide these screens and away we go. All right, welcome. This is the second version of this. We did it, I think it was last week for the first half of you guys. I'm Ryan Hoger. I work here at TEC, as you probably are painfully aware. My info is on the screen as well as Dave Herman. He's in our tech support group. And actually, the reason why we're both on the slides is because a year and a half ago when we made these slides, we thought we'd be doing all these topics on refrigerants together. But as it turns out, almost everything is exactly the same as 410A. So don't really need Dave on most of these. All the changes are really controls related, which is why usually you get me. But I'll go through everything in general. And just so you know, this is like a 1 hour and 10-minute version, if you will, of what is normally a 2.5 hour class we do with customers. So we're obviously not going to do the show and tell part physically, all right? And we're not going to go through the installation stuff in super deep detail. If you need that, if you're someone who's into that, then you should come to one of the refrigerant classes we've been hosting. We've done like 65 of them since the last 13 months. So they're all every week somewhere, right? Next week is Loves Park. Ask questions as we go. I'll try to look at the question chat box thing, but if you want to just blurt them out, that's totally cool as well. So as you probably know, we have to get the global warming potential of all of our refrigerants down lower. Specifically, it's got to be below 700. I know my slide says 750. That's because originally it was 750 and they changed it to 700 for who knows what reason. There's no refrigerants between 700 and 750, so it was a waste of time from your government. But in any case, R410A, which is our most common refrigerant that we use today, is 2088. So it's not even close. It's like 3 times too much. So we got to pick a new refrigerant or refrigerants, plural, that are below 700. So in the terms of timeline of this change happening, it's significantly faster than the R22 to 410A transition. We started that in 1996 with 410A coming out, and we didn't get rid of R22 until what, 5 years, 6 years ago. So it was a pretty long transition, 20 plus years. This is not that. This is basically a 1 year transition, if you will. New refrigerants just started coming out last year, as far as most manufacturers are concerned. And by the end of this year, we're not going to have 410A. So maybe like a 2 year transition if you want to count from the beginning to the end. So things that are happening. There are two schedules of things happening simultaneously, and they're not in sync with each other because that's how governmental things work or don't work. Starting in 2022, the refrigerants, meaning R410A, 134A, 407C, all those HFCs that we use in our industry, those started being phased out in 2022, and the manufacturers of refrigerant are only allowed to produce 90% of what they used to make back in like 2012, so like 10 years prior to that. The next step down happened last year, where they can only make 60% of what they used to make 12 years prior to that. And then it just keeps like chopping its way down until we finally get down to 15% in 2036. And then it just stays there at 15%. It doesn't actually go down to zero. So in 2063, if somebody wants to manufacture R410A refrigerant, they can do that, but they have to do it at 15% of what used to be made in 2012. So it's a pretty small amount. Whereas R22, it went down to, well, almost 0.5%, which is basically zero. So the refrigerant's being phased down, as you're aware, or hopefully aware. And then the equipment that uses those refrigerants is being phased out. I'm going to skip most of these in the interest of time, and I'll focus on two specific categories. One being split systems. This would be residential, traditional split system, harness and AC. This would be a commercial split system. This would be a ductless mini split. Anything where the contractor field connects the piping. If it's field piping, it's a split system, right? So in those cases, all of those pieces of equipment have to be manufactured or imported to the United States by the last day of 2024, which had already happened, obviously. And they have 1 year to get that stuff installed. So it has to be installed by the last day of this year. December 31st, 2025 is the last day you can legally install a 410A split system. In contrast, we have package systems. Package systems would be a rooftop unit, a gas pack, like one of those magic packs, and an NCP type unit that goes through the wall, a water source heat pump, something where the factory pipes it, not the contractor. If it's factory piped and it all ships to you in one box, that would be a package system. It still has to be installed or manufactured by the last day of 2024, which already happened. And you have 3 years to get that installed. So someone could install an R-410A rooftop unit manufactured last year as late as December 31st, 2027. It's not likely that's going to happen, but it could happen. The rest of the stuff on the chart is a little more specialized. If you have questions on that, we can talk about it separately. But package and split is what applies to 99.9% of our customers. Everything else is pretty special. There is the opportunity for a manufacturer of equipment to go ahead and produce what's called a service-only condensing unit, where they can continue making a 410A condensing unit this year and indefinitely with no end date, as long as they wish. However, there's a couple of caveats to that. One, it has to be specifically labeled for service only. So there's little pink tags all over the place saying this is for service only. It'll have a slightly different part number than we normally would have. But with that being said, pretty much no manufacturers are doing this. The first challenge is that in order to comply with energy code in like 47 states, you have to have a SEER rating, which comes from AHRI. And the only way to get a SEER rating for most stuff is to have a matching indoor and outdoor coil. So if we have these service only units and there's no matching coil associated with them, which there's not, then you can't get a SEER rating and you can't comply with energy code. So because of that, the manufacturers are not building them. If it's larger than 135,000 BTUs of cooling, which is 12.5 tons. So if it's larger than 12.5 tons, there's actually a mechanism to get an outdoor condensing unit rated without any indoor coil. I don't know how they do it, some kind of magic, right? But there is a way to do that. So above 12.5 tons, it is possible that a manufacturer can still keep producing 410A condensing units this year, and they could be installed on existing air handlers only. You cannot put a new air handler or coil in there. It has to be go on an existing one. And it's meant for like if the condensing unit fails. With that being said, at the end of January, Carrier already stopped making 60 tons and up. And then a couple weeks ago, they stopped making 20 tons and up. And I would not be totally shocked if another one of these bulletins came out and said, hey, we're not even making 12.5 to 20 tons anymore. So pretty much consider it to be almost a dead topic. So therefore, everything's got to be the new refrigerants, right? There is, so the service only thing is the condensing unit only, not the air handler. But there is the ability to forever, with no end date, manufacture evaporator coils for furnaces. That's not part of any of the phase down for 410A stuff. So Carrier could keep making evaporator coils forever for 410A with a 410A TXV on them. There's no end date to that. But for condensing units, it's what I just described. For air handlers, it's already over. For fan coils, it's already over. They can't make any of that stuff. But evaporator coils, they can. I suppose the idea probably is, hey, if somebody has a 410A failed evaporator coil under warranty, it's significantly easier just to swap the whole coil than it is to keep the coil cabinet and just pull the guts out and swap that. So that's probably why they're doing it that way. There is one manufacturer, ADP, which I don't believe we're currently stocking any ADP stuff. We have over the decades, but I don't think we have anything recently. ADP has a coil called a flex coil, which allows the manufacturer's representatives, distributors like us, to stock one coil. And that coil, when it's sold at the counter, the purchaser of the coil, the contractor, could say, I would like that with a R22 piston, please. I would like that with a 410A TXV. I would like that for R32. I like that for 454B. So one coil, and they tell you what kind of refrigerant they're going to use, and then you would hand them a TXV that they would field pipe on there. And if they bought a flammable refrigerant, you'd also have to hand them all the safety controls. That's the idea with that ADP flex coil. However, there's like a lawsuit type thing happening with them to blockade them from doing that, with the main concern being people are just going to come in and say they want R22 or 410A, and they're really going to put it on R32 or R454B, and they're not going to buy the required safety controls that would normally come with an evaporator coil for those refrigerants and skirt the rules. That's the concern, and that's the reason why they're getting kind of blockaded. So I would not anticipate this going on. Well, it's a legal thing, so who knows how long it can go on. But my guess is that they'll probably get blockaded because they're the only ones doing it. All right, with that being said, let's move forward. 410A in the dust. We're going to new refrigerants. The EPA has this thing called the SNAP rule. The SNAP rule defines all of the various refrigerants that can be used for various types of applications. The six refrigerants you see on the screen right now are the ones that the EPA has approved for use with residential and small commercial equipment that has scroll and rotary compression in it. Um, there are different refrigerants that you can use for centrifugal chillers and screw chillers and stuff like that. But for your normal everyday stuff, this is what we got to work with. All six of these refrigerants are flammable. So no matter what, people are getting a flammable refrigerant. And unfortunately, there's multiple solutions to one problem here. So R32, Daikin owns the patent on that. So Daikin's obviously very interested in using R32 instead of R454B. Additionally, Daikin already has R32 in Europe and other places. So for them, it's a matter of changing it from 50 hertz to 60 hertz power and importing it to the United States, right? So the Daikin and the Daikin family of products, which would be Goodman, Amana, and those folks, they're all going R32. Here at TEC, we have Gree stuff, as you guys probably know. Gree is R32, as are several of the foreign manufacturers. Right, so Gree's made in China, Gree's R32. Carrier for very large condensing units and very small scroll chillers, it also has R32, right? Everything else, and Train has, and their very large condensing units has R32. Everything else has R454B. So Carrier, Bryant, ICP, all the residential stuff, all the regular rooftops, actually all the rooftops, all the commercial, smaller and mid-sized condensing units, Train, Lennox, York, right? Ream, American Standard, like all that stuff's R454B. So obviously Daikin and their products picked R32 because that's already their thing, right? Everybody else picked R454B because it has a lower global warming potential. And at the time they were picking this, 9 years ago, they were told that the global warming potential limit was going to be 500. It was 500, then it switched to 650, then 750, then finally 700. So most people, manufacturers, picked the lower one and figured, hey, that's the safe one to go with. Whereas Daikin folks picked what they already knew, what they already had in their portfolio, and then either hoped or presumably lobbied to get the limit to be above what they have. So that's how we end up with two different things. So you will have customers coming in and you'll be dealing with them from an R454B standpoint and an R32 standpoint. But most of what you guys are going to see at our locations are R454B. Looking at some of these side by side, this is 410, this is 32, this is 454B. We don't care about the other ones right now because nobody's using those for HVAC in the United States, so it doesn't make a difference to us. If you are unaware, any refrigerant with a 400 number, 400 means it's a blend. It's two or three things mixed together, right? So 410A is a blend. 410A is actually 50% R32 and 50% R125, right? R32 is not a blend. It is a single refrigerant. And then all these other ones are also blends, usually with R32 involved in there. As you can see, 410A has too high of a global warming potential, so it's out. The other ones are low enough so they can all be utilized. From a capacity standpoint, like how much energy can the refrigerant hold? Not the capacity of the equipment, because that's also a function of compressor and coil and fan and etc. But the actual refrigerant itself, R32 can hold a few more BTUs per pound than R410A could do, and R454B is a few BTUs less. COP, which is the efficiency, both of these choices are like one tiny tick better than 410A, like not even enough to get excited. Like what used to be a 15.2 SEER unit might be like a 15.3. It's like not a big deal, but it's better's okay, right? There is evaporator glide on everything except R32. All blends have an evaporator glide. That just means that the two refrigerants have different boiling points. So theoretically, if you have a leak, specifically have a leak in the evaporator where the refrigerant's converting over to a vapor, one could leak out at a faster rate than another. If you were here with me in the 1996, 97 time frame, this was a big deal. People were all concerned about it. Contractors were freaking out. Oh, dude, if we have a leak, we're going to have to reclaim all the refrigerant and put all new refrigerant after we fix the leak. No one has ever done that once on 410A. They pump it down to the machine, they fix the leak, they let the refrigerant go back into the system, and then they go ahead and top it off. Right? No one ever does that. But theoretically, that would be the case. 454B also has glide. By the way, this isn't degrees Kelvin, not that you and I care about degrees Kelvin, but 1 degree Kelvin at an evaporator temperature is like 2.5 degrees Fahrenheit. So there's a slightly different difference in the boiling point, but not much. And as you can see, from a pressure temperature standpoint, it's pretty similar to what we're used to now. It's not like switching from 22 to 410A where the pressures went way high. These are all in the same general ballpark. Let me see if I can open up a PT chart real quick. So this chart, this one's nice because it has all these refrigerants in there at the same time. So this is 410A. This right here is 454B. Oops, I clicked on. And this is R32 on the far right-hand side. So if we look at like an evaporator, like say 40 degrees or something like that, R410A would be 123 for pressure, or sorry, 118 for pressure. R454B is slightly less at 107, and R32 is slightly more at 121. But general same ballpark. Look at the outdoor side of the equation, let's say 120 degrees. I'm at 419 for 410A. I'm at 396 for 454B, and we're at 429 for R32. So same general ballpark, but in fact, different. If anybody has any questions, type them in that little, chat box, or just go ahead and blurt something out, and I'll hopefully be able to hear you if my speaker's working okay. But ask anything you want. The more questions, the more better. Otherwise, I'll just keep talking. As mentioned, 410A is 50% R32 and 50% R125. R32 is the flammable one. This is the one that's causing all these refrigerants to be flammable, but it's in 410A, and that's not considered flammable. That's because R125 is basically a flame suppressant. So flammable thing and flame suppressant mixed together means non-flammable thing. In the case of R454B, we also have R32, which is flammable, right? We have 69% of that, but then we have 31% R1234YF, and that is also flammable. So two flammable things mixed together continues to be a flammable thing. I made fun of this slide when they gave it to me like a year and a half ago, because I'm like, what's with the no propane thing? I'm like, Ryan, people think there's propane in this refrigerant. And I was like, who the heck thinks that? Like, no one thinks that. But I've been pulling people in class. I did this morning. I pulled people in class. I had 36 people in class this morning, and I would say close to 30 of them said that sometime in the past 12 months they were told there's going to be propane involved with residential and commercial refrigerants. And there's not. There's no propane in this discussion. There's no propane in R454B. There's no butane. There's no isobutane. None of those bad rumors that you heard. There's only 3 ingredients in R454B. It's R32, R1234YF, and then oil. That's it. That's all you get. There's nothing else. So whoever's telling you that there's propane is completely misinformed. Over here on the right-hand side, you see this box with the 8 little boxes in it. We've had this chart forever. This comes from ASHRAE Standard 34, which defines all the refrigerants. ASHRAE are the people that assign those R numbers. They're the one that tells you, you get to be 410, you get to be 454. Like they assign those numbers to you based on your chemical compound. And a bunch of other stuff that comes up too. But in any case, they've had the standard for decades and decades and decades. There was always 6 boxes in the past. Now there's 8. Previously, on the left side was the A's, the right side was the B's. A meant lower toxicity, B meant higher toxicity. Obviously, we'd like to stay in the A's. Sometimes you can't. Like if we do an ice arena, there might be an ammonia chiller, just the way it goes. Train for a while had R123 chillers, although that got phased out. But there's been times we've had these toxic refrigerants. There's all kinds of rules associated with that, but it's usually for special projects. We'd like to stay in the A, non-toxic category. Then we had 1, 2, and 3 to indicate how flammable it was. 1 means what I would call non-flammable, but technically it's no flame propagation. It is flammable because you can burn those things. You can burn R410A, right? You can burn R22. It's just that when you take your torch away from it, it goes out on its own. It doesn't keep burning. It won't propagate the flame. So it's basically non-flammable. So that would be A1s. A2 would be flammable, and A3 would be like highly flammable, like propane, right? Or butane, which we are fully aware burns, right? So the A1 refrigerants, they're all gone. Every single one of them, with the exception of CO2, is too high of a global warming potential for us to utilize anymore, right? It's not allowed. CO2 is allowed, but that's a whole nother set of problems we have in terms of temperature and stuff like that. So no one's using CO2 in the United States for HVAC. So there's no A1s available to us. So we have to go up into the A2 bucket, which means we have to go flammable. So there's a bunch of ones, specifically 6 for HVAC, that are on the very bottom of this flammable bucket. Like they're just right on the line here. And what the ASHRAE folks did is I assume that they wanted to put them down in the A1, but you can't change something after it's classified decades ago, right? Nothing changed about the property of the chemicals. So like, what are you going to do? So I think what they did is they just created another bucket. They're just like, dude, what if we make another bucket and we take all the stuff that's barely an A2 and we call it like A2 light, like just like a little bit flammable. And that's how we get A2L. It's the refrigerants that are flammable, but just barely flammable, like not even as flammable as a regular A2. To give you some scale to this, on this drawing on the bottom is how fast this stuff would burn. Up the left-hand side is the heat of combustion. We're usually get this zoom bar out of my way. We're usually over here on the far left side, meaning it doesn't propagate flame. Right? We're A1s. We're on the 0 line, right? Avoid all problems. The new A2L bucket is this dotted line right here. And our new A2L refrigerants are the ones that are in this orange, yellow, gold, whatever you want to call that, right? Those are our new A2L refrigerants. Let's see, there's one A2 on here. It's R-152A. That is used in hairspray. If you ever taken a lighter and a can of Mom's Aquanet, you can make a flamethrower out of that. If you had a good childhood, you probably did that, right? But it obviously burns fairly easily, right? It burns pretty quickly. It's gone, right? But it burns pretty easily. In contrast, propane is way over here on the far right-hand side. It's an A3. It burns fast and has a lot of BTUs in it. It's pretty flammable. Obviously, you have a propane grill at home. You know what I'm talking about. R600A, by the way, is sometimes used in refrigerators. I was in the Minnesota office we have, as you guys know, and I was doing a class up there. One of the guys was like, yeah, there's R600A in refrigerators. And I was like, that's BS. There's no way they put in A3s in people's houses. And there's a mini fridge in the room. He spun it around. And there's a big sticker on the back, R600A. I was like, okay, maybe they are. It's a very small amount of refrigerant because it's a mini fridge, right? But nonetheless, it's in there. Was that a question or no? Maybe not. All right, so we're going to live over here in the bottom left-hand bucket, things that are flammable, but not super flammable. On the right-hand side is a list of stuff that will not ignite an A2L refrigerant. So I guess people can hook up HVAC while they have a cigarette dangling out of their mouth. It's probably not a good plan, but it's not going to light anything on fire. The ones people ask about a lot are like household appliances, like a toaster. Like, what if Mrs. Jones has a refrigerant leak at her house? She wakes up in the morning, she pushes the toaster button down to make her toast in the morning, and that just ignites the house up and it goes down in a ball of flames, right? That's not going to happen. It's not enough. A toaster can't light it. In fact, she can unplug the toaster, walk down in the basement, plug it back in, push the button down, and angle it so the refrigerant is coming out of the coil that's leaking and blowing right into the toaster, and it still is not going to be enough to light it. Toasters and hair dryers don't have enough energy to actually light it. There are things in people's buildings and houses that can light an A2L refrigerant, but it's not those types of things, right? It's going to be like open flames. It's going to be like a acetylene torch from the technician. That would do it. Like down at the bottom, there's some examples over here, right? So there are things that can do it, but it's not going to be your normal everyday, household appliances. It's not like your TV's going to turn on and a spark's going to happen and it's going to light refrigerant. All right. Last one of these, and then we'll keep moving. Right here, minimum ignition energy. It's in millijoules. Not that you and I know what millijoules really are, but here's R32. It takes 30 to 100 millijoules, which is, a lot of energy, if you will, to light it. R-454B is 3 times as hard as R32 to light. But if you look over here at propane, for example, it's 0.25. It's super easy to light propane. You can bang 2 rocks together and light propane on fire, right? You push one little spark button on your grill and it lights it, right? Sometimes it's operated off a 9-volt battery. It's enough to light propane, right? That's not going to happen with these kind of things. They're much, much harder to light. If you were unaware, most cars, actually all cars, have A2Ls in them now. You can't buy a new car without an A2L. The auto industry started 11 years ago switching over to A2L refrigerants. This screenshot is from 6 years ago, where 50% of the cars sold in the United States had an A2L refrigerant in them. specifically R1234YF, which, as I told you a minute ago, was one of the ingredients of R454B. That's what your car has in it. If you bought a car recently, that's what it is. This is the most current chart I could find on cars. It's from 2021, where like 90% of the cars had an A2L refrigerant. There's no newer chart because now all cars have it. It's 100%. So with 100%, there's no reason to make a chart. So all cars have an A2L refrigerant. The car you drove to work in today very likely had an A2L refrigerant in it, unless you're driving a classic car from 1973, and then you're just awesome. So the point is that people are already having these refrigerants in their life. They might have a fridge with an A3 in it. They might have a car with an A2L in it. And now we're all freaking out about HVAC. HVAC is one of the last industries to switch over. And the United States is one of the later developed countries to switch over. Everybody else is already doing this. Like, this is not rocket science. We're just really slow in our industry. We're like at the tail end over here, right? We resist change for some reason in HVAC. So point being, it's already in your life. You may not know it. You got to roll with it at this point. So stuff that's specifically going to be different. This is stuff we'll hit on today. Talk about what's happening with cylinders. That'll obviously affect you guys. Storing stuff at your building. I'll mention to you what's going on with transportation. Even though you guys aren't driving a service van, you may be getting those questions. Some safety equipment, any tools that technicians are required to have, what they have to do differently at installation and service points, and then specifically we'll talk about the dissipation controls that are required by law. So the cylinders, as you guys know, cylinders are already painted gray. They all switched to gray. I don't know why. We had a really good thing going with the color scheme, and then Crayola got all antsy about it. Like, you guys got to stop using all the colors, cut it out. So now everything's gray and boring, and that's what it is. And you got to read the tag to see what you have. A2Ls are also going to be gray and boring. The difference is they're going to have a red band painted on to let you know they're an A2L. So this jug right here for R454B looks exactly the same as a jug for R32, and you'll have to actually read what it says on there to know which one you have, because visually, it in fact will look the same. But in any case, they're all gray. They're also going to have left-hand threads, meaning it's not righty-tighty to hook your gauges up to it. It's lefty-tighty, which is super weird. That means all the contractors need to have an adapter. I've been giving them to everybody at the training classes for the refrigerant when the technicians come. I've been giving them one. I don't even know how many. We've given away like 1,400 of these adapters. Tim Roberts is like, why are you giving away so many adapters? But it's just easier to give everybody one, so they got a fighting chance of doing this work later on. But then obviously some of you guys have them in your stores and you're selling them as well. And plus, guys are going to lose them because, well, it's small, and that's what guys do. We lose stuff. In any case, they're left-hand threaded, so you need an adapter on there. Current refrigerant tanks have a pressure relief disc, and the purpose of that relief disc is if the pressure gets too high, this metal is thinner right here in the edge of the disc, so that disc will pop out if the pressure in the tank gets too high, and then it'll relieve the charge that way. As opposed to making everything super strong and tight, including this spot, and then it would have to explode and like shrapnel would go everywhere. Whereas now we're not going to have that. Instead, we have a pressure relief valve on there. So on the new tanks for R32 and 454B, there's a pressure relief valve. The difference being the pressure disc, if it pops, if it ruptures, the whole charge of the tank is gone. It all leaks out, right? The relief valve will open up, dump enough pressure out of the tank to solve the pressure problem so it doesn't blow up, but then it'll shut back off, right? So it's a 20-pound tank. Maybe it opens up, lets some refrigerant off to get to a safe pressure, and now it's an 18-pound tank, and it hasn't completely been a disaster and lost all the refrigerant. So because these tanks are different relief and different left-hand threads on there, that means they're not the same as the ones we have, obviously, but they're, for some reason, in high demand. The manufacturers of refrigerant cannot seem to get their hands on enough of it in order to package the refrigerant and ship it to us. So you probably have already heard people asking, like, when are we going to get refrigerant, right? And we get small amounts here and there, and then we're out again. Like 20 minutes later, we're already out of refrigerant. There's not enough to fulfill the demand. There's enough refrigerant, like the refrigerant physically exists in tanker trucks. There's not enough of these small 20-pound cylinders to put it into. So that's the backlog on that, which is obviously causing issues with people in the field installing this stuff, because they can't get refrigerant to charge systems. So hopefully that goes away sooner rather than later. Recovery cylinders, they are also going to continue to be gray with a yellow paint on top. The difference being the A2L ones will have a red band on them as well. They'll have the left-hand thread, and they'll have the pressure relief valve on. Storing stuff, There's a lot of rules that kick in when you have more than 10,000 pounds of refrigerant. Um, but you don't have that at any of your branches or anywhere in our company. So we don't have to worry about those particular rules. At your local branch, as well as at a contractor's office in their shop, there are rules that they are required to follow in terms of how they store this stuff. Um, the short, brief answer of this is you got to keep all the stuff separated. And that's the current rule for current chemicals you have in your store. You can't put everything, just like mix it all together, right? It's all got to be separated out, right? You don't want uh, uh, flammable, highly flammable things like acetylene and propane sitting next to other things that could burn, like an A2L refrigerant or whatever. So you got to keep those things separated, which hopefully you guys already do. So that should be no problem, but just in case. Technically, you have to have all the material safety data sheets for every chemical in a building, any chemical you're storing. You got to have a safety data sheet for that and all the associated paperwork. This is not new for this refrigerant. This is for all refrigerants, including A410A and R22 and all chemicals, acetylene and whatever else you guys have. You have to have all this paperwork. I don't know if you have it. I don't know if someone's given it to you. I don't know if anyone's ever asked you for it. Just telling you what the rule is. You're supposed to have that stuff, in your facility and ready to go. And then there's little placards in your storage facility that you have on each. So maybe you keep all your acetylene in this one little metal cage. And then over there, you keep all your R-454B in this other little metal cage. On the side of the metal cage, there's little diamonds on there that tell you what's in there. The only really thing that's different now than what we've had before is now something shows up in the flammable section. Whereas before, there was no flammability, so for our refrigerants, so it didn't matter. But now there's a flammable portion to it. For customers, contractors, the rules changed for them last year and got easier than we thought they were going to be. We thought they were going to have to ventilate their vehicle. I don't even know what that means. You cut a hole in the roof and put those little crank camper things on it or whatever. But you don't have to do it anymore. The vehicle no longer has to be ventilated. We thought they were going to be prohibited from putting their tanks in a horizontal rack, and you had to store them vertically. That rule changed, and now you're allowed to do horizontal. And then they were supposed to have to do all the U.S. Department of Transportation placarding on their vehicle, and that also went away. So Chemours and the refrigerant manufacturers went to U.S. Department of Transportation and talked to them about if this stuff counts as materials of the trade. I'm putting it in quotes because I don't know exactly what that means, but somehow if you have a service van and you're transporting materials for your trade of work, HVAC, to be installed at a project site, that makes you legally different than a delivery truck driving down the road. Even though you may both have the exact same quantity of chemical in your vehicle, somehow you're different than they are. And as long as your total chemicals do not exceed 440 pounds, you don't have to do any of the placarding or the ventilation or any of that stuff, right? You don't have to do it for a service van. If you're a delivery truck and your job in life is to drive around delivering chemicals, you're in a different category. But for a service van, you don't have to do any of that stuff. There are some other limits. I don't have a slide for it, but equipment transported can be a maximum of 26 pounds in that piece of equipment. So the biggest thing you're going to fit into a service van is like a 5-ton unit. And even then, some of them don't fit, right? A 5-ton unit, and a 5-ton unit's never going to have more than 26 pounds in it. So you're good. You're no problem there. But if you had a bigger vehicle, you would not be able to have any single piece of equipment with more than 26 pounds of refrigerant in it. If you need to go higher than these things, because obviously there's equipment that's transported with more than 26 pounds. I mean, not a service van, but on other vehicles, you have to get a permit from the U.S. Department of Transportation. The good news, not that getting permits is ever good news, is that if somebody else has already pulled a special permit, you don't have to like rewrite your permit from scratch. You can just use their permit, right? So for example, if you need to transport equipment that has between 26 and 44 pounds of refrigerant, which is super odd, right? You don't have to pull a permit. You can use the existing Daikin permit that they already have. Say like, I'm going to use this one, and you could cite this one. If you need a lot more than that, like up to 5,000 pounds in a piece of equipment, which is a ton, you can use the train permit. If you want to transport cylinders of refrigerant more than 20 pounds, a normal R-454B or R-32 cylinder is only 20 pounds. But if you want to transport more than 20 pounds, specifically 20 to 125 pounds, Chemours has a permit that you can use. So if you can get your hands on a 100-pound cylinder of R-454B, which is a thing, you can buy it that way. I don't know if we have any of them in our inventory yet, but you can buy that. Then you would just use this Chemours permit in order to be able to transport it. Questions? I know I'm talking fast. That's just kind of how I roll, man. If there's questions, blurt them out, or like I said, type them in the chat box. So far, no one's typed anything in, so I assume that I am doing everything the most perfectly way possible, which probably is not accurate, but hey. All right, so some overview on the safety things. Um, you're required to wear glasses and gloves when you're handling refrigerant. Um, Not in your guys' case if you're carrying a jug of refrigerant to the front counter. That's not a gloves thing. If you're going to be opening the valve on it, that's a gloves type thing. So contractors need to have glasses and gloves. That's what they're supposed to do with 410A anyway. Some of them don't do it. A lot of them don't do it. Although my class today was pretty good. It was like 75% of them were wearing gloves, which is amazing. So just keep those kind of rules in mind. As far as tools go, um, real quick, there's a few different things to mention on that. And I'm sure you've all had, Field Piece or JB or whoever in at your store to talk about tool things. But I'm going to give you kind of the rundown. For guys that have digital gauges, it's very, very likely the gauges already have R32 and R454B in them. They probably haven't checked, but they can scroll through the various refrigerants available. It's probably already in there. If it's not in there, several guys have told me that they've been able to take a USB cable to their laptop, download the new software, and push that into their gauges via USB cable and update it that way so it has the new refrigerants in there. One guy specifically told me he's able to download it onto his phone, into the app for his gauges, and his gauges talk to the app via Bluetooth, and he was able to update it that way. If somebody's got, if it's the first guy who ever had digital gauges 17 years ago, he's probably frozen in time. He probably can't update anything, but most guys should be able to do something. Analog gauges, that's different, obviously. There's no updating on those. So it is what it is. You can use your R410A analog gauges on R454B if you wish. You have to just not look at the pink band of temperature in there, completely ignore the existence of that, and just read the pressure only, because the gauges measure pressure, and that just correlates to a temperature. Read the pressure, and then take that pressure and go to the chart I showed you a few minutes ago and see what temperature that correlates to. Obviously, after 2 or 3 jobs, that's going to get annoying, and people are going to want to just go ahead and buy 454B gauges that already have the sticker with the right temperature in the back of the gauge, so they don't have to go back and forth with a chart. So I'm assuming you guys have analog gauges at the counter for sale at this point. I know last year when I looked, we didn't have anything, but I'm assuming you got it by now. Other things that would change, obviously, refrigerant leak detector. There's no reason to use an R22 leak detector to try to find R32. Like, it's a different thing. So you just have to have a leak detector that actually can find the chemical you're looking for. Anything with a motor in it has to be A2L compatible listed. So recovery machine, vacuum pump, anything with a motor has to be basically a non-sparking motor. It has to be listed as A2L by that manufacturer. So some of the stuff guys own is totally fine. In fact, a lot of what they own is already fine. I would have been telling everyone to do is just take the model number of your piece of equipment, go to that manufacturer's website, and they will either have a list by model number of all the things that are compatible, or they won't have that. And you'll go look up the thing that you own, whatever model number that is, and read the spec sheet for it, and it'll tell you what refrigerants are allowed to be used on it. Right, and find it one way or the other that way to see if what you already own is good. And you might not have to buy a ton of new tools. Some guys are going to need new stuff. Not everybody's stuff is compatible, right? But some guys will need new things, but not every single person, every single tool. It just depends on what it is. From a general thought process on installation, it's actually pretty easy to explain to people what's going to happen. You just do everything the same. So all the things we've been telling the people, the field to do on R410A, right? And by we, I mean the industry's been telling them to do this. This is a good idea, best practice stuff. All the things we said that are best practice, just switch from best practice to being flat out required. So we've always been, not always, but for 20 years, we've been telling people purge and evacuate the line, right? We've been telling people to do that. And if they've been doing that all along, then this is no big deal. You just keep doing everything the right way and you'll be fine. If you've been doing everything by cutting corners, well, then yeah, you're not doing it right and you won't be doing it right in the future. You'll still be jacking it up. But as long as you're doing all the good practices on 410A, R454B is all the exact same stuff, at least from a refrigerant standpoint. It'll be a little bit different when we talk about the control widgets here in a second. Reclaim cylinders, as mentioned, left-hand threaded, painted yellow, red band on them. Ideally, people would not mix refrigerants in them. You definitely cannot put A2Ls into a regular reclaim cylinder. It has to go into one of these ones. I mean, you could do it. You could force it in there, right? But from a safety standpoint, it needs to be in the one that has the right safety controls on it. As you guys probably know, we have an exchange program at TEC where people bring us back cylinders that are full and we give them an empty one, right? Or they can just bring us back a cylinder and not get an empty one. That's also possible, right? And we'll pay them for that cylinder. It was 99 or 120 bucks when I had the Melrose Park store look it up for me a couple weeks ago. And then you could also get an empty tank from us, right? So net, they're paying like 40 bucks or whatever to exchange it. But that's been going on at most of your guys' stores now. And then no matter what you've heard people say, R-454B and R-32 are not drop-in refrigerants. You can't take them and put them into an R-22 and R-10A system. I mean, you could do that, but like it wouldn't be safe. It wouldn't be allowed. There's actually no reason to do it because you can't even get R-454B in any large quantity, right? So, but it's not a drop-in replacement. It's not like an MOE 99 kind of thing. R-410A stuff goes in R-410A equipment. R-454B refrigerant goes in R-454B equipment. R-32 goes in R-32. Do not mix and match those things. Just to keep things moving, left-hand threads I mentioned. The filter dryers that come with the residential condensing units have straight connections on them now. It's the same technology in the filter dryers we had for 410A. In fact, 2 weeks ago, Mark Wiseman and I sat there and looked them up just to see, and it's the same manufacturer, same specs. It's just whether the connections are swedged or whether they're straight on there. So you can use one from inventory that's a regular filter dryer that's swedged on there. You can put that on 454B. Obviously, this one comes with the unit, but maybe they used it and they got plugged up and now they need a new one. You don't have to have this exact one. You can give them another version of it. In any case, it's straight stubs on the side. The coil has straight connection on it as well, and the outdoor units have straight connections on them, as opposed to being swedged. Swedged means it's like flared out a little bit, so you can stick the pipe inside there. The reason that they're straight instead of swedged is that they are now designed to be used with press fittings. You are still allowed to braze. This question's come up a lot. I've had several guys in class tell me that our stores have said, no, you can't braze anymore. You gotta do the tool thing. You don't have to do that. You can braze. Brazing is allowed. However, the manufacturers have made it easier for the guys that do want to go ahead and switch over to press, right? If this connection's press and that's press and that's press and this is press and the one next to it's press, it's easier to press, right? Whereas before, it was a little bit of work to press, right? Because everything was set up for brazing. Now they're making it easier for the press guy. If you want to braze, you can do that. You just got to put a
Thank you for
coupling on
calling
there.
National Excelsior in Hudson. This is Dave. How can I help you?
Dave, you're off mute. So let's make it easier for the guys that want to do the press fittings. And obviously, you guys know we have press fittings at a lot of our locations now. So if anybody does want to switch, we have the fittings, we have tools. Obviously, the fittings cost more money, but it is significantly faster. The guys I've had in class, every single person except for one has said it's been faster for them once they switch to press versus brazing. So there is advantages to it. If you can save labor, I guess you're willing to pay more for a fitting. All the equipment, indoor, outdoor, residential, commercial, it's all going to be labeled. Obviously, there'll be little red flammable diamonds on everything. It'll tell you it's an A2L. It'll tell you what one it is, 454B. Like, that's kind of stuff you expect, I suppose. Evaporator coils have a yellow hang tag on them. So when you go to connect it up, you're like, oh, I didn't realize I had R54B. I grabbed the wrong coil, right? So trying to make everything labeled and very, very clear for everyone. From a charging standpoint, setting things up, things are the same as what we've been doing in the past. They want us to, or they want the technician rather, to do a 500 micron level vacuum, and then over the next 10 minutes, not have it rise more than 1500. That's a pretty normal-ish type of request. So not really anything different than 410A would have. Charging is done in the liquid state for 454B, just like it is done with 410A. That means when you charge, the tank gets turned over, so you're pulling refrigerant from the bottom, i.e. liquid, as opposed to the top where there would be vapor on there. So unlike R22, which was a single refrigerant, R410A and R454B are blends. So when it's a blend, we want to charge it in a liquid state. So nothing different there. From a charging standpoint, there's also nothing different. If it's an inverter, most manufacturers of inverters for 410A or 454B or R32 want the contractor to weigh the charge in. That's the normal way to do it. Weigh it in. If your line set's longer than the book says, it'll tell you how much math you got to do to figure out how much extra to weigh in, right? That's what we normally do for an inverter. And we want to do it that way normally because the inverter is kind of ramping up and down. So it's kind of hard to do it any other way and not have it keep tweaking on you. If it's a single stage unit or a two-stage unit, a non-inverter, then in those cases for R410A and R454B, we're charging via the subcooling method. That's the normal way to do that. So it's the exact same method. No change there. And just like with 410A, they want you to charge it with the coil having the indoor and outdoor coil being more than 70 degrees. Um, it's always easy to get the indoor coil above 70 degrees. Just run the heat for a while, and then the room will warm up, the building will warm up, and then you'll be above 70. Outdoors harder. You're not going to warm up the whole outside. You're supposed to charge when it's above 70. Obviously, there's people charging today, and it's in the 60s. People got to do what they got to do to keep functioning, right? So it is what it is. But ideally, you'd be charging when it's above 70 degrees outside for 410A and 454B. Line sets is a very common question that comes up a lot. So there's three different scenarios here. Move this little zoom box out of the way. The first one on top, R454B with brand new piping, so a brand new line set. They want you to purge and evacuate the line set. So you purge it with nitrogen to clean all the debris that could have got in the line, evacuate it, and then you're good to go, right? So on a new piping, purge and evacuate once. If you want to do a double evac, you can do that. If you want to do a triple evac, you can do that. No one's going to complain that you did extra work, but single is all that's required. If you have an existing R410A piping system and you're going to keep the piping and you're going to convert the equipment over to 454B, you are still only required to purge and evacuate. It's the exact same process. Nothing else is required. You're not needed to do a chemical flush or anything like that. In fact, I didn't know this until 13 months ago, but Carrier actually does not permit the use of R11 flush. Those, the RX11 flush kits, those aren't allowed by Carrier. The tech support group here at TEC has informed me more than 10 times to tell people that that is not allowed by Carrier. We cannot use our X11 flush on R410A or 454B. I know people do. I know we sell it at the counter. I get it, but it's not something that's approved for use. And you don't need it, especially in this case, because it's the same oil. It's not even an issue there. If they have existing R454B or R32 piping, so they have an existing flammable refrigerant inside the pipe, that is the only time you're required to do double. So you're going to evac and evac, purge again. Or excuse me, purge and evac, and then purge and evac again. You're going to do it twice. I don't know why. Maybe they just figure you didn't do a good job the first time. Do it a second time before you open the pipe up, right? So in any case, that's the case there. Questions on that? There are some guidelines related to some accessories. I've minimized most of them because they're weird things that we don't even use. But there's one that comes up a lot. This would be electronic air cleaner. This is more residential. I mean, it could be commercial, but it's mainly residential. If you have an electronic air cleaner or electronic air purifier, in other words, a filter with wires to it, if your filter has wires connected to it, you're required to have an airflow switch. This is the kit number for Bryant Evolution, Carrier Infinity, or the ICP air purifier. That's the kit number that you'd have to provide them with the filter itself, the filter rack itself. So this airflow switch just proves that there is, in fact, air moving through the filter before power is allowed to be applied to the filter. Historically, we've just interlocked this to the EAC terminal on the furnace, but apparently that's not good enough anymore. That just says the fan is supposed to be on. It doesn't prove the fan is actually on. So now we have to have a pressure switch or a sail switch or something that actually proves airflow. It's my understanding from the dealer meeting on Tuesday that this kit is now shipping inside, included with the air filter from, the Infinity Air Purifier filter. However, depending on what we have in inventory, you may or may not have it. So if you have an old one, you got to provide the kit. And if you have a new one, then obviously you're fine. And obviously, if you're providing the old one on a 410A system, then you don't even need the kit at all because you don't have to worry about it. Good on all that? Questions? I feel like one person at one point in time should ask a question so I know that you're alive. Like one thing. Like just type something in or blurt something out verbally. Think about it. Ask one thing. All of these systems are required to have dissipation. By all these systems, I mean residential splits, commercial splits, rooftop units, mini splits, VRF, all of them have to have a dissipation system. There's like one exception to that. I'll mention that later. So the idea with the dissipation system, there's two types of dissipation. There's passive and there's active. Passive means if the refrigerant leaks, I need to have enough space for it to leak and spread into. Dissipation means it's going to spread out so far that I won't be able to actually light it. So, for example, if you went to the gas station, right, and you took your lighter out at the gas station and started pumping gas and tried to light the gas as it was coming out of the nozzle, you probably could get something happening there, right? You could probably make a cool flamethrower, right, and take some buildings down. However, you get out of your truck at the gas station, take a deep breath, you smell gas in the air. You know there's a little bit of gas floating around in the air, but you can probably take your lighter and click it several times, and it's not enough gas in one spot. It's too dissipated to actually get it to ignite. So that's what they want us to do. They want us to dissipate it. On the outdoor unit, it's not a problem because on the outdoor unit, it's outdoors. So if there was a leak outside, it would have the whole earth to dissipate to. It'd be plenty of space. The inside is where things get limiting. So we have to have a space big enough, a house big enough, a building big enough, etc., for it to properly dissipate. So that's the passive dissipation. There's also going to be an active dissipation here in a second. So for the passive dissipation, if it's a split system, we'll look at how many pounds that the system was final charged with, and then there's a certain minimum square footage. Technically, it's cubic foot, but nobody wants to start calculating cubic feet of a space because people aren't good with math, at least not in HVAC. So they made this square footage chart, assuming that every ceiling is 7.2 feet or smaller, which 7.2 feet is pretty small. So for example, if I take this chart and I go, okay, I got 11 pounds of charge in this system, it cannot service an area of a building or home that is less than 167 square feet. That's not going to be hard to do. 167 square feet is a 16 by 10 room. This is a super small building. Like only 16 by 10 is the whole building, and you have 11 pounds of refrigerant. What are you doing in this building? What illegal activity do you have going down, right? It's not going to be hard at all. So for residential splits, commercial splits, rooftop units, it's super easy. You're going to be no problem. Mini splits, no problem. The time it's going to be a problem is when you have multi-head systems. So for example, if I have a rooftop or a furnace and I have a leak in the evaporator and refrigerant's leaking out, that leak will go into the duct system and it'll be distributed to all of the rooms that are ducted to that rooftop or furnace. So the whole house, for example, would get all of the leak and it would spread out between all of that. However, if I have a multi-head mini split system or a multi-head VRF system, I might have one evaporator coil sitting in Mrs. Jones's home office, and her home office may be a 10 by 10 room, 100 square feet. If she has 11 pounds of charge in her system and her room is 10 by 10, that's not big enough, right? Because in her case, if there's a leak in the evaporator, it only goes to one room. It doesn't go to the whole house like it would on a ducted system. So multi-head mini split is when you'd have to pay attention. Otherwise, it's going to be pretty easy to comply with this. If they have packaged equipment like a rooftop unit, it works the same way, but instead of looking at how many pounds they have and then the square footage, it's going to be based on the model number because the unit already comes with the certain number of pounds in there, right? So if I have the 030, 48K 030, I need 725 square feet. It should not be hard to get 725 square feet of space serviced by a 28-ton rooftop unit. I think we're going to be fine, right? It's not the tonnage, it's the model number. So this is a 48K 30, 725. This is a 48V 30, 1013. They're not the exact same unit. They have different coils. One holds more refrigerant than the other, etc. But either case, there's a chart like this to look at. The second half of that discussion is active dissipation. So active means there's going to be a sensor involved. Every single evaporator coil, there's one exception I'll mention later, but every single evaporator coil has to have a factory installed leak detection sensor on it. You're required to have that. They have to put it in there for you in the evaporator coil. So a rooftop has to have it, a commercial air handler, a residential air handler slash fan coil, a evaporator coil for a furnace. Whoever provides the evaporator coil has to give you this refrigerant leak sensor and any controls required to do the sequence I'm about to describe. So if I have a Bryant evaporator coil and it's going to sit on top of a 17-year-old Duquesne furnace and it's going to connect to a Lennox condensing unit, it's a weird combination of stuff, I know. Bryant has to provide me that sensor and the controls for it. Even though Bryant didn't provide the actual refrigerant in the machine, but they provided the evaporator, so they're on the hook for that. The sequence of operation is as follows. If there's a leak detected, so if we get to 20% of the lower flammability limit for any given refrigerant, in this case 454B, it detects a leak. It is required to shut off the condensing unit. That makes sense. There's no reason to keep trying to run the compressor with refrigerant pouring out of this thing, right? So shut off the condensing unit, shut off any sources of heat, meaning gas furnace or electric heater. I think they're concerned that there'll be a leak in the evaporator coil. It'll migrate down into the furnace cabinet. There might be a hole in the heat exchanger of the furnace. So now it migrates its way to the igniter. And then we try to turn the furnace on, and the igniter will, in fact, go ahead and light it because that's definitely a hot enough surface temperature to ignite refrigerant. So that's their concern there. So no cooling, no heating if there's a leak. And then the fan goes on, which to me at first sounded weird. Like we're going to turn the fan on and we're going to blow the leaking refrigerant all over these people's house. That's weird, right? I'm like, yeah, Ryan, it's called dissipation, bro. Like we're trying to dissipate it and spread it out. If we spread it out, nothing bad's going to be able to happen. We won't be able to light it. So we are, in fact, going to blow it all over the place. Okay, so be it. So no heating, no cooling, fan goes on. It does that for 10 minutes. And assuming after 10 minutes there's no leak, which there probably won't be because you blew all the refrigerant somewhere else, then it goes ahead and runs the sequence for 5 extra bonus minutes. No heat, no cool, fan on. And after a grand total of 15 minutes, it allows heating and cooling to resume as normal. Obviously, cooling's not going to be very useful because you don't have any refrigerant, but the heating at least would go back to heating this person's house. And then if there's another leak detected later on, it all repeats again. No heat, no cool, fan on, wait to 10 plus 5 minutes. If everything's good, we're ready to rip, right? So you can do that, or it will do that, I should say. And there's a circuit board that comes with this. This is the same circuit board fundamentally in a rooftop unit, fan coil, furnace, etc. There's 4 places to wire stuff on there. The top on the white up here is the refrigerant leak sensor. That's where it wires. This is factory installed in the evaporator coil and wired to this board. If you have a rooftop, a commercial air handler, a residential fan coil, or ductless mini split, you don't have to install anything in the field. It's all factory installed for you. You don't do anything weird. The only thing you do, instead of wiring your thermostat to the equipment circuit board, you wire it to the leak board. And then the leak board will eventually pass it to the equipment circuit board. But you don't have to install any of this stuff. If it's a residential furnace split system, you have to install this stuff because they don't know whose furnace you're going to have. Are you going to reuse an old furnace? You getting a new furnace, right? Is it this brand? Is it that brand? They have no idea. So in that case, you're going to get the factory installed leak sensor with a harness dangling out of it, out of the evaporator coil, and you're going to plug that into a board, and you're going to wire the board to the condensing unit in the furnace. Not you, but whoever's installing it. Down the bottom left, there's this 8-pin harness. Red and black are to power it up. It gets power from the furnace or the equipment transformer. And then the other 4 wires is heating, cooling, and fan. Or excuse me, other 6 wires is heating, cooling, and fan. There's a cooling in, cooling out, so Y in, Y out. There's a heating in and out, W in, W out. And there's a fan in and out, G in and G out. Because all this board does is it sits between the thermostat and the equipment. So the thermostat calls for heat on W. Instead of going to the equipment, it goes into this board on W in, and it leaves on W out and goes to the actual equipment. And this board has the ability to blockade the heating and cooling call if needed and force the fan on. In the upper right, you see that green block. That's if they have a communicating system. So Bryant Evolution, ICP Ion, Carrier Infinity type system. As you may know, those systems do not have regular thermostats. They do not have a W, Y, or G signal to intercept. Those don't exist. So it's being done differently on those. And there's a communication cable that attaches from here to the communicating equipment, and it gets its signals that way. And the bottom right-hand side is a miscellaneous alarm contact, which a year ago I initially thought was a waste of time, but it does have some pretty good uses. For starters, on a commercial building, you may choose to wire one of these contacts to a building automation system. If a rooftop or air handler has a leak, it can notify the BAS system that there is a leak, and then hence the building operator can get an email, text message, screen pop up, whatever it is, saying that, hey, you got a leak on rooftop 6, right? So it can do that kind of stuff. It can also turn on idiot lights on a panel or make a little buzzer beep or one of those kind of things. In other applications, residential and light commercial, we've been using this on zoning systems. So if you have a zone damper system, like say a Honeywell True Zone, for example, right, a Honeywell zoning system or any brand, Jackson Systems, Zone X, California Economizer, zone first, like whatever this thing is, an old Troller temp, any zoning system. If I have zone dampers and there's a leak and I force the fan on to dissipate the leak, the dampers have to open up. If they're shut, it's kind of hard to force the fan on. So all the dampers have to go wide open. On really simple systems like a Honeywell True Zone system, the dampers are simple two-wire dampers and they have a spring that pops them open. And then when you don't want any air in that zone, the controller powers it closed. And if for any reason it shuts power off, the spring pops it open. So the easiest way to get all the dampers open is to kill power to the zoning board. So the 24-volt power for the zoning board, we run it through the normally closed and common contact. So the R wire from the transformer of the furnace comes into normally closed, it leaves on common, and then it goes to where it was supposed to go on the equipment board. And if for any reason there's a leak detected, it kills power to the zone board. All the dampers go wide open and all the thermostats go blank. If this board does detect a leak, there are a couple lights on here. This orange light right here, or amber, or whatever that is, it'll flash once if it's seeing a leak right now. And after it does not see a leak, but it's finishing up the bonus sequence of no heat, no cool, fan on, it'll flash 3 times. As mentioned on a fan coil, it's all factory installed, right? Residential fan coil, commercial air handler, all factory installed, no special wiring needed. If it's a furnace, then it's field installed. There is one time they're going to have to move the sensor. So the sensor is factory installed in the evaporator coil on a slab, a V coil, A coil. It's factory installed on there. And in some cases, we have coils that are what we call multi-poise, meaning you can run them vertically, air moves through them this way, or horizontally, air moves this way. So this one here is a multi-poise. There's a drain pan here and a drain pan there. The sensor needs to be at a low point of the coil. If you did not know it, refrigerant is heavier than air. It'll pool low. So in this case, if you take this whole thing and you turn it on its side, that's fine because this is still the bottom corner. It's a different corner, but it's still the bottom and it's okay. If you have a V coil, it's also fine. It goes in the bottom of the V coil. Life is good. But if you get a V coil multi-poise, meaning a drain pan here and a drain pan here, and you mount it on its side, well, what used to be the bottom now becomes the middle, and it's in the wrong spot. So you have to take 2 screws out, slide it down over here, and put the 2 screws back into the screw holes that are already there. And now your leak sensor is at the bottom again. So there's one time that they have to relocate it on a multi-poise V coil for a furnace. That should be the only time. The board, this board comes in a plastic enclosure if it's a furnace. It ships to the customer in a brown, not obvious cardboard box underneath the evaporator coil. So you take the evaporator coil out, you set it on top of the furnace. And if you've ever opened a box for an evaporator coil, we have all those little corner posts in there to protect it from getting smashed. Although somehow you guys are smashing them at the warehouse. I don't know what you guys are doing. But in any case, you lift the evaporator coil out, put on the furnace, the little cardboard crap falls in there on top of the box with the controller in it. The box becomes a trash bin now. Your wonderful helper takes it out to the dumpster. You're going to come back tomorrow to finish the job. And you're like, where the hell is my board? Right? I'm saying that because you're going to get people that are like, oh, I never got a board. It never came with it. Yeah, it was probably under the evaporator coil. And you probably threw the box away and didn't know it. Right? So tell people to look for that thing in there. It gets mounted separately. So for all the equipment, it gets mounted inside the equipment, except for furnaces. For some reason, furnaces doesn't get mounted inside. I don't know why. Maybe it voids the UL list thing. I have no idea. I've gotten different answers and none of them sound plausible. So it just can't. I don't know why. It cannot be mounted in water. That seems obvious. It cannot be mounted in the evaporator coil. There wasn't any space. Can't put it inside the ductwork. Didn't want to do that anyway. And you can't mount it in the furnace, which I said is weird. I don't know why. Where can you mount it? You can mount it on the side of the evaporator coil. And if it's a V coil, you mount it low so you don't poke your screws into the coil. If it's an A coil, you mount it up higher. You could also mount it on the back wall. You can mount it on the side of the furnace. Don't mount it up here where the heat exchanger is. Mount it down at the bottom where the blower section is. You can mount it on the return duct. You have several different options there. But for whatever reason, it can't go inside the furnace. As mentioned, when you're wiring it all up, all the wires are actually labeled. There's little tag, you can't really see very well, but there's little tags on every single wire, and it tells you where the wire is coming from and where it's going to. So it'll say something like W into T-stat or something like that. So it's pretty well labeled. 4 of the wires have those like, I don't have a picture. Four of those wires have those C connectors on them that fit really cleanly under the thermostat strips. It's almost like a spade connector, but it's in the shape of a C, and it fits under these thermostat connections on the furnace circuit board. So four of them are going to go there. Three of the wires are bare wires with nothing on the end of them. Those are going to get wire nutted. And then one of the wires is the piggyback spade. They're going to pull the secondary wire for the transformer that goes to the circuit board off, put the piggyback spade there, and plug the transformer back in. That way, this board can get power directly from the transformer. Even if the furnace board takes a dump for some reason, it doesn't work, the alarm board will still be functioning. I don't know why that matters, because if the furnace board's not working, I don't know who's supposed to put the fan on, but at least you'll get the alarm blinking light, right? We already talked about the communicating ones, so we can skip that. There's one button on that board. If you press that button one time, it'll run a 60-second version of the sequence. So instead of 15 minutes, it'll do a 60-second version, just so the tech can make sure everything's wired correctly. By the way, we did the two in Melrose Park last, I don't know, May or June. Two different guys installed it from the same contractor, both like 15 years experience. Both of them wired it wrong. Granted, they didn't come to the class. They didn't probably read the book, but they both wired everything wrong. Everything was working. They thought it was all working. Heat function, cooling function. They charged the unit. When I pressed the test button, nothing shut off. Because what they did is they took the thermostat wire and they went right to the furnace with it. Whereas the thermostat wire needs to go into the leak board and then to the furnace. All they did is wire the thermostat to the furnace, and then they wired the leak board to the furnace, and then the thermostat had a way to turn everything on without going to the leak board, and hence it was useless. All the fans, whether it's a furnace, a fan coil, air handler, rooftop unit, the fan speed has to be set up. The minimum fan speed has to be set up so it has at least the minimum of these charts, enough to dissipate the problem. So if we go back to our 11-pounder refrigerant example, we need at least 293 CFM whenever the fan is enabled by the thermostat. As mentioned, there's alarm codes on the blinking yellow light. The green light is for the communicating systems. So you get two lights there. The yellow one is the one we normally pay attention to. For regular stuff, meaning residential and small commercial, there's 8 possible flash codes. I had mentioned specifically 1 flash, meaning there's a leak, 3 flashes, meaning we're finishing up to 5 bonus minutes of dissipation. But there are, in fact, other ones. The sensor, if it's not working, it can send a message to the board saying, hey, I don't feel good today. I got the flu, bro. I'm not coming in. Like, I'm done. Like, I'm baked. So it could send a message like that. And there's also a few wiring errors that could generate a blinking light. But basically, you're counting the blinking light, reading the book to see what it says about that, right? So, 3 flashes. Check for refrigerant leak, with a refrigerant detector, right? Those kind of things. If it's a bigger rooftop unit, it may have a board in it that can handle 2 sensors, in which case I will inherit 1, 2, 3, 4, 5 more flash codes for the second sensor on the board. And there's even a few rooftops that could have as many as 3 on there. Okay. I already sure to mention that, so we're good. From a replacement part standpoint, there are probably 3 new things that you're going to need to have at the store. You're going to need to have refrigerant leak sensors. You're going to need to have the dissipation control boards. I think Tim said we're stocking this stuff in Melrose and Lansing right now, but eventually all of the locations are going to need it because it's going to be an everyday thing. And you're going to need to have A2L listed contactors. You cannot put a regular contactor into an A2L system. I mean, you could do it, like electrically it would work, but it's not allowed. The new A2L contactors are more enclosed. They can be spark proof, if you will. So you have to have A2L contactor. You could put an A2L contactor on a regular A1 system, but I don't know why you would do that. But so you guys are going to need contactors, sensors, and leak boards. You probably don't need to stock a bunch of TXVs because I don't imagine that you stock a bunch of TXVs now. Somewhere in the company we need them, but like probably not every location. And the filter dryers, you don't really need to stock the R-454B filter dryers because I said earlier you can use an R-410A one. It's the same media. It's going to have the same rating on it. The only difference is whether it's straight pipe or it's wedge. So you probably can get away with not adding anything in terms of a new part number there. All the equipment, as you would anticipate, has a part number change in it somewhere to let you know you have the new refrigerant. This is a simple fan coil. Right? I won't go through every single piece of equipment with you. Just know there's a digit that changes on everything. Rooftop, like whatever. It's a guide digit that changes. The one that's a little weird is a furnace evaporator coil because it actually has 2 digits different in there. one of them to tell you that you have the new refrigerant. In this case, the third digit switches to an A to tell us that we have Pure Advanced R-454B. And the 11th digit tells us that it came with the dissipation control board, um, which originally was supposed to be called a mitigation board. And the lawyers said, no, dude, you're not mitigating, you're dissipating it. Change the name. So now it's a dissipation board. Although I think the part number guy's he's a little bit too far down that path. So you're going to get an M on some of these. But it'll be two digits on there. And I believe the reason for this is going to be at some point in the future, they will be selling us evaporator coils without the mitigation controls for warranty replacement purposes. If you have a leaking coil, you don't need new controls. You just need a new coil, right? So I think that's why they're going to have it separated. Although right now, it all comes with it because nobody has a warranty yet because it doesn't exist yet, right? For you guys that are used to carrier part numbers, it was 24 and 25 for residential AC and heat pump. Now it's 26, 27. Bryant works a little bit differently, but you can have 13, 14, 19 for AC, 23, 24, 29 for a heat pump with the new refrigerant, right? Builder grade model stuff, same kind of thing. The day and night stuff, it's the second digit that switches right here to a 5 on there. Same on the AC as the heat pump, no change, no difference between the two there, right? Everything has that. The ICP coil, same thing. This digit right here tells me that I have R-454B, and the 8th digit tells me if I have M for dissipation instead of M for mitigation, right? Which sounds stupid. Or R, meaning it's a future replacement only coil, no controls, right? So I won't go through all of these just so you know. Ductless is a little bit different because ductless always is communicating. The indoor and outdoor unit always talk to each other. Nobody makes non-communicating ductless anymore, and it's not for decades. So they're always communicating. So there is no leak board on there. There's no dissipation board. There's just a sensor that plugs into the regular board that's already in there, and that board has software in it that tells the outdoor unit to shut off and the indoor fan to turn on. There is one weird caveat that can happen with the ductless stuff. Uh, Everything's going to be that way I just described for the top tier and mid tier, but for the low end entry level type ductless stuff, those units are not going to be coming with a refrigerant leak sensor. If you are under a certain pounds of refrigerant, the leak sensor is not required at all. You don't have to do it. I forget what it is. Depending on whose article I've read, it's like 3.91 pounds to 4.4 pounds. So something in that range. So let's just for argument's sake say, hey, if it's less than 4 pounds, you don't have to have a leak sensor. So a window unit, no leak sensor. A P-TAC in a hotel, you don't need a leak sensor, right? And in some cases, these ductless mini splits, if they're relatively small coils, they don't have a lot of refrigerant volume. And if they tell you, hey, keep the piping length less than XYZ, they can thereby say you don't need a refrigerant leak sensor. You could still buy one if you want and plug it into the board, right? If you want to, or if your piping is so long that it needs to, but you don't necessarily get it automatically like you do on the higher end stuff. Rooftops also changing, as I mentioned. The digits change. You know, if you guys are used to a 48FC, now it's a 48FE. The GC becomes a GE, right? Different TXVs, dissipation controls, same kind of control board as we had before, leak sensor, still tripping at 20% lower flame limit. Everything's exactly the same as the other stuff we talked about. The one weird thing on rooftops I want to point out is that if the rooftop is less than 15 tons, the leak board will be found in the return air section. If it's more than 15 tons, it'll be in the control enclosure. Obviously, it belongs in the control enclosure. It's just there's no more space on a small unit. You have an IGC board, contactors, transformer. You got the EcoBlue speed control board. You got economizer control. Like you run out of space. There's no more space to shove another board in there. So they're sticking it in the return air now. If it's bigger than 15 tons, then the cabinet's bigger. So they got more room for more boards in there. So you'll find it in the control enclosure then. As mentioned, some of the rooftop units have 2 or 3 sensors in there. There'll be a not awesome drawing showing you where this stuff is supposed to be located to try to help you find it, right, on any given rooftop unit. And there's the part numbers for the boards and sensors if you're trying to hunt them down. Just like residential, on rooftop units or commercial air handlers, depending on how much refrigerant you have, or in the case of a rooftop, what model number you have, because that's how much refrigerant you have to have a minimum CFM set up on the fan speed when you set the fan up to be able to make sure that you have enough. The fan can go higher than that when you get a heating and cooling call, but the fan by itself needs to be at least that high. So that's published in every single manual. All I did was screenshot that out of every manual. And then we already showed you these ones and the bigger ones. So, air handler is commercially exact same thing. Nothing's different than anything I just said. It's all the exact same thing. There'll be a minimum CFM that you have to have. There'll be one or two sensors depending on the model of the unit. So no matter what it is, CFM, minimum square footage for the room, everything's exactly the same. What questions do you guys have? Nobody's asked one single question, like a totally question-free zone here. I'll just sit here for like 2 hours waiting for a question. All right. If you don't have anything you want to ask or type, that's totally cool. I'll assume that you know everything. Um, uh, question was, oh, okay, I don't have a question, but the tool portion was helpful. All right, cool. All right. If you do think of a question, obviously you can send me a note or give me a call. As you probably know, I teach classes every morning, but usually late afternoon, early evening, I can call people back when I'm not teaching class or in mid-June. All right. Thank you guys for your time. Appreciate it.
Thank you.